Hello everyone. Previously we had discussed on the topic this one, expression evaluation algorithm, right? So we had discussed that one. So today we'll be discussing on the topic stock span algorithm. So let's get into the definition part here. So what does the stock span algorithm say here? The stock span algorithm is used to find the number of consecutive days before the current day for which the stock price was less than or equal to the today's price, right? So this is simple. Again, let me read this one out loud. Just listen to this carefully. The stock span algorithm is used to find the number of consecutive days, right, before the current day for which the stock price was less than or equal to the today's price, right? So basically what it does, it helps analyze the stock's trends and investor confidence, right? So that's what it does. So let's get into the explanation part. So just listen to this carefully. Whatever I show, you can just observe carefully. So this itself will be implementing or articulating in the form of code or this one algorithm, basically by making use of the Python programming language. Just listen to this, right? So let's imagine we have the stock prices for n days, right? So let's imagine we have the stock prices for n days, suppose 1 2 3 4 like that prices, or 10 20 30 anything, right? So for each day we want to know how many days in a row including today, right? So for each day we want to know how many days in a row the price was not lower than today's price, basically, right? So lower than the today's price, basically. This is fine. So what would be the straightforward approach here? So, or the naive approach here, for each day we have to look backwards until we find a higher price, right? So this one would be big of n square. This one would lead to big of n square. So the optimized approach using the stack. So basically by making use of the stack, the optimized approach, we can just go with the optimized approach by making use of the stack. So what we will do, we will be making use of the stack to keep track of indices of days, basically, of the days, basically. Just remember this, we'll be making use of the stack just to keep track of the indices of days. Then we will be traversing the prices one by one, right? For each day we'll be having certain price for each day, right? So then we will be traversing prices one by one while stack is not empty and the current price is greater than or equal to the price at the top of the stack. Then only we will pop. If stack becomes empty, then what we will do, span is nothing but I plus 1 in that case, right? Otherwise span is just I minus top of the stack, right? So this point is I hope this point is clear, man. This one, right? After this one, traversing prices one by one, we will be going with this step itself. While stack is not empty and the current price, if it is greater than or equal to the price at the top of the stack, then we will pop. If the stock becomes empty, span is I plus 1. Otherwise span is I minus top of the stack, right? So we will be pushing the current index onto the stack, basically. This reduces the time to this one big of n, meaning time complexity would lead to big of n, basically, right? So final step is we'll be pushing the current index onto the stack, right? So this is fine, I believe, man. So let's try to implement the same thing in the form of code, right? So let's do one thing. Let me go with stock span. So this is fine of prices. So this is also fine. The first step would be here, let's go with the total number of days. So this one will be n equals length of, let me pass prices here. Have considered for this is not showing. Yep, this is fine, man. The next step would be we have to go with the result array just to store the span for each day. So this one will be span equals 0 into n. So this one has to be multiplication operator. This is fine. Finally, let me go with the stack, nothing but the, I'll just go with the variable st here. Let me initialize this one with the empty array. This is fine. We are just making use of the stack to store the indices of the days as we had discussed. Finally we'll be pushing the current index, this one index onto the stack, right? So let me initialize this one to the empty array. This is fine. So first we have to go with the first day span, that is always 1, right? So this one we have considered the variable span, right? Span 0. Let me initialize this one to the 1. The next step would be we have to push the index of the first day into the stack, nothing but stack st is the variable we have considered. So this one let's append 0, value 0. So this is fine, I believe. The next step would be so the first step, what we have to do basically here, this one, we have to traverse the price one by one, right? So let's go with a for loop here. So this one will be for I in range, this one is nothing but 1 comma n. This is fine for I in range 1 comma n. So we have to pop the elements from the stack where while current price is higher or equal, right? So this one is fine, man. Let me go with a while loop, stack and prices of I. So this is fine. So if it is greater than or equal to prices of, so this one will be stack of, so this one will be -1, right? So this is fine, man. Yep. At that point, what we need to do, we have to pop while stack is not empty and the current price is greater than or equal to the price at the top of the stack, as we had discussed. So we have to pop at that time. So I'll just go with the stack dot pop. The variable we have considered is st, right? So this is fine. Now let's move on with the next step. So if the stack becomes empty, then we have to go with this one. The span is nothing but I plus 1, right? So I'll just write on this way: if not st, sorry, what did I do, man? So let me come here, sorry, stack dot pop here. This is fine. If not st, so this is fine. Then what we'll do, let me go with span of I. So this one equivalent to the I plus 1. So this is fine, man. Right, else what we will do, this one, otherwise span is the difference between current day and the last higher price day. So this one will be span of I. Let me assign this one to the I minus st stack of -1. So this is fine. Yep, the final step would be we have to push this day index into the stack. So this one will be stack dot append of this one I. So this is fine as well. So let me do one thing. The final step would be, let's return the span. So this is fine. We are done with the coding part. So the next step would be, let's go with the example usage, right? So let's print something for the interactive purpose, man. Let's consider the example here. So I'll just go with the prices here. So let me give some random prices. So here this would be, let me consider 100, 80. Also let me go with 60, 70 as well. Let me go with 60, 75. Let's go with 2 or 3. Let me finish with 85. This is fine. Also let me assign the result to this one. Let me call the function stock span here. Stock span of we have to pass the prices, right? Beta prices. This is fine. The next step would be let's print the initial prices, man. Right, so let's print the initial prices. So this one, within the strings, I'll just give prices. So this is fine. I'll just go with prices here. So this one, let me go with the prices. Sorry, print again. So let me go with span. This is fine. Fine. This one, let me go with the result. Yep, this is fine. Yep, prices as well as the result. So this one initial prices and this one is the result that we need to get basically, right? So let me explain whatever we have written, so that I can just run the code after that, right? So n equals length of prices, whatever I have written in the line number 30. So this one is nothing but we are finding the number of days, right? So this is to find the number of days basically. So then we are creating the result array that is initialized to 0, this one, line number 31, right? So st equals this one, we know we are making use of the stack to store the indices, right? So let's come to the next part here. This one, first element has always span equals 1, right? So we know this one. So this is nothing but first element always has the span equals 1, right? So that's what I have here initialize this one to the span of 0 basically. Now for each new day, what we are doing here, for each new day here, we are popping while today's price is greater than or equal to the price at stack's top index, this one, right? So this part, right? So this is fine. If the stack is empty, then span equals I plus 1, so this part, right? So then we are going with this one. If the stack is not empty, then span is equivalent to the difference between current index and the stack's top, this one, right? So accordingly with what we had discussed on the this one explanation part, the same thing we have implemented or articulated in the form of code, right? So this one, let's come to the next final one. So we are pushing the current index to the stack here. We are pushing the current index to the stack, line number 46, right? So this is fine. Finally we are returning the this one, what do we call result, basically that is stored in the span. This is fine, man. Now we are pushing the current this one index to the stack, and finally we are returning the this one result that is stored in the span. This is fine. Now let's run the code. I hope the algorithm part is completely clear, man. Whatever the code that we have written basically, right? So let me give Python here. So let's go with the file name. So this is the file name, right? So let me copy this one entirely. So let me paste it over here and this one, right? So the output that we got here is 11112146, right? So we have got the desired output here. This is the initial price, 100, 80, 60, 70, whatever we have considered, that itself we are displaying, right? 85, this is fine. Prices, the output that we got here is 112146, which is absolutely correct. So how it works basically, how it works, so we have discussed. If you didn't understand, let me tell this one again. So day one, what we have basically, we have 100. For the day one we have 100. See here, this one I'm speaking of. For the day one we have 100, right? So we have no previous days for this, right? Span, initially the span will be 1, so span I'll write directly, this 1 is nothing but the span, right? For the day 2, so we have the value 80, right? So for the day 2 we have 80. So previous higher was this one, basically previous higher value was 100 basically, right? Again span remains same, 1, right? So day 3 we have the value, what value we have here, 60, right? So this one, previous higher value was 80 basically. This one again the span remains 1. So for the day 4 we have the value 70. For the day 4 we have the value 70. So previous days, this one, previous days we had 60, right? So previous days we had 60, right? So now this 60 is basically 60 was smaller, right? So but 80 is greater than 70 here. 80 is greater than 70. So this one, day 2. So this 60 is smaller than 70, but 80 is greater than 70, right? Basically, so span becomes, instead of span equals 1, span becomes 2 here. This is fine because 60 is smaller than 70. This is fine, man. Now we have to move to the day 5. Day 5 we have value 60. Day 5 we have value 60, right? Day 5 we have value 60. We have to consider 60 itself, right? So only itself we have to consider. So now this will be 1 itself. Span remains 1 itself, right? So let's move on with the day 6. That is nothing but the values 75 we have, 75 and 85 we have, right? The last two values. 75 we have to consider. Here this beats 60, 70 and 60. This beats 75 beats 70, 60, 60, 70 and 60. See, 80 is greater than 75, but 75 beats 60, this one, 70 as well as 60, these three values, right? Last higher was 80. So span is 1, 2, 3, 4. Now the span becomes 4. That was how it was 2 here, right? So this had beaten 60 and higher was 70 basically. That is the reason we considered 2, span 2 here. This 75 beats 3 basically. 60, 70 and 60, and the fourth one was 80 is greater than 75. So overall span is 4 here, right? Span is 4 here, right? So this is fine. Finally we have the value 85 at the day 7. 85 value 85, right, at the day 7. So basically what it beats until 100. See, we have the 85, so 85, this beats 75, this beats 60, and this beats 70 as well, because 100 is great, 85 is greater than 70, and this beats 60 as well, because 85 is greater than 60. This beats 80 as well, because this one, what do we call, 85 is greater than 80 as well. And finally 85 is smaller than 100, so this doesn't beat 100, so we'll stop here, and we have to consider this one. Totally 1 2 3 4 5, and finally this 100 is greater than this 185. We have to consider this. Totally it will be 6, right? Span equals 6, right? So the output that we got here is span is nothing but 1 1 triple 1 2 1 4 and 6, right? So what is the output that we got here? 1 1 2 1 4 6. So this is how we got the output here, 1 1 2 1 4 6, right? So I hope this one is completely clear, man. Span part is completely clear. How we got the output is completely clear, right? So we have got the desired output, and whatever the algorithm that we have written works absolutely perfect, right? So this is fine, I believe. Now we are done with the stock span algorithm, right? So now as we have completed the stock span algorithm, let's do one thing. Let me summarize whatever we have learned so far, right? So just try to remember these 2 to 3 points. This is very important. The stock span algorithm, what it does, it calculates how long the stock price has been rising or stable up to the certain day, right? So this is what it does. And naive approach or the straightforward approach would lead to big of n square time complexity, right? So we have optimized this one with the stack that would lead to the time complexity big of n. So whatever the algo we have written, this would lead to the this one, time complexity big of n, basically. So this is very useful in financial data analysis, right? So this is very helpful or useful in the financial data analysis to understand the stock trends, just remember this, right? So I hope this one is clear, man, right? So I hope this one is clear. So we are done with the stock span algorithm, right? So basically we are done with this one, what do we call, stack and queue based algorithms, right? So next we'll be moving on with the tree algorithms, right? Tree based algorithms. So we'll be starting with the DFS or BFS tree traversals, right? So we have so many algorithms. Let me tell you once. Basically we'll be going with the DFS BFS tree traversals. Morris traversal is there. We'll be going with the diameter of a tree algorithm. LCA, binary lifting, right? So LCA, nothing but the least common ancestor. So this one we'll be going with the binary lifting or the RMQ, range minimum queries, right? So this is one of the algorithms, 4 algorithms, and this one, fifth one is validating binary search tree, balanced binary search tree conversion. This might consist of the AVL red black tree as well as the tree as well, right? So this is fine. Next we'll be going with the segment tree algorithm, lazy propagation in the segment tree algo, and persistent segment tree algorithm. Then we'll be going with the Fenwick tree or BIT algo. Then we'll be discussing heavy light, this one, decomposition algorithm as well, right? Heavy or light decomposition algorithm. Then we'll be discussing about the centroid decomposition as well. So we have made use of we will be making use of the centroid when it comes to when we solve the DP on trees, this one, DP on trees, this one problems very recently in the, while solving the this one, what do we call, basically what do we call, when we were solving certain problems using this one, what do we call, DP, well, we applied the DP on the trees or dynamic programming on trees. So we went with the centroid decomposition, if you remember, right, along with the number theory, by making use of number theory as well, and the centroid decomposition on many problems. If you remember, we used it on many problems. Basically centroid decomposition, that is also one of the important algorithms that we'll be discussing. Finally we'll finish it off this one with these two, basically Euler-Tour technique as well as the square root decomposition on the trees. Total we have around basically 14 algorithms, I believe, tree algorithm. So this will be fun actually, right? So we are done with the stack and queue based algorithms. So let's finish it off with this one, stock span algorithm, right? For this particular playlist. For now, this is it. Thanks for watching, guys.